Hi, everybody. It just looks like we have a couple more people trickling in right now, so let's wait a couple seconds here. I hope everyone's first week back to classes is going well. All right. All right. So hi again, everybody. My name is Andrew, and I'm just going to be here today to introduce Dr. Sean Ovens, who's going to be doing a lesson on object-oriented programming in Python. So Dr. Sean Ovens is a postdoctoral fellow at the University of Waterloo, and his research focuses on the theory of distributed computing. He's particularly interested in proving lower bounds on the time and space complexities of distributed algorithms, and enjoys studying concurrent data structures, randomized algorithms, and recoverable algorithms. So as we can tell, he's very qualified to be teaching you all here today, and I'll hand it over to Dr. Ovens.
Okay, thank you very much for the introduction, Andrew. So just give me, I think I'll need permission to share my screen as well. If you have a second.
For sure. And everyone, I just also shared a link to a Google notebook here. So just, there you go. The one better make you comments. Yeah. All right, there you go.
Perfect. Okay, there we go. All right, yes, thank you again for the introduction. So hello, everybody. It's great to meet all of you. Again, my name's Sean. Today I'm going to be talking about the basics of object-oriented programming in Python. So this is an introductory course, so I'm only going to be assuming that you've learned just the fundamental programming concepts like conditionals, loops, functions, and so on, which I believe you will have covered last November. So I'll try to move through the content slowly, and I will discuss solutions to all of the exercises that I present in detail. Again, the exercises are present in the Colab notebook that Andrew posted to the chat a couple minutes ago. So if I'm going too fast, or if I say anything that doesn't make sense at any point, just please stop me whenever you want. So I'm going to be presenting slides during this workshop, but again, I've written all of this material along with the exercises that we'll be doing in that Google Colab notebook, so you can follow along with that, or you can look at the slides if you prefer. All right. So I was going to start with an introduction, but I think Andrew covered all of this already. So again, I'm a postdoc at the University of Waterloo. In case you don't know where Waterloo is, it's like an hour-and-a-half drive west of Toronto, biggest city in Canada. This picture here on the left is just a picture of the computer science building there. All right, and as he mentioned as well, my research, at least during my graduate studies, focused on the theory of distributed computing. This is just where a bunch of computers, I guess distributed computing is where a bunch of computers work together to solve some problem. So a classic example of a problem in distributed computing is consensus. Every computer begins with an input, for example, some number, and everybody just has to agree on a single output value. So those are the kinds of things that I study. And in my postdoc so far, I've been studying more practical things, I guess, non-volatile memory allocation and memory layout visualization for multi-threaded applications. All right, that's enough about me. So I'm going to start this workshop with a bit of a review slash warm-up exercise. I'm sure November feels like it was a long, long time ago. So the main purpose of this review is both to, of course, review the programming concepts that you've learned so far, but also to motivate the idea of object-oriented programming just by presenting a simple scenario where object-oriented programming actually helps us out quite a bit. So let's suppose that we work for a bank and we need to represent bank accounts in a Python program. So a bank account consists of the following three pieces of information. First, it has the name of the owner of the bank account, it has an account number, and it has the current balance, so just the amount of money that's stored in the account. All right. So using just I guess the basic skills that we learned in November, what we could do just as a first approach is to store each of these pieces of information in its own separate variable. So if I wanted to represent an account that I owned, I would create, again, 3 variables, one to store my name, one to store the number of my account, and one to store the balance of my account. Now, if I only needed to create one bank account for myself, this strategy works just fine. However, I will most likely need to be able to represent multiple bank accounts in my program. Of course, if we're writing this program for a bank, then the bank is going to need to represent all of their customers' accounts in your Python program. So the problem with this particular approach is that if I need to create another bank account, I just need to create a whole new set of variables for every single account that I make. So if I wanted to create an account for someone named Mia, for example, then I would need a whole new variable for her name, whole new variable for her account number, and another one for her account balance. All right. So, of course, this approach isn't all that great because we're going to have a lot of variables floating around if we need to work with many bank accounts at a time, and we most likely will. The variable names become very long and unwieldy because they need to be descriptive enough that I, as a programmer, can clearly distinguish between different accounts. Another slightly more subtle issue is that there isn't actually anything besides the variable names that binds the account information together, right? This is a problem because let's imagine we have a withdraw function that works on our bank accounts. So what the withdraw function does is it takes an account name, a number, and a balance as arguments, and then it just takes some amount of money out of our bank account. Then we could do weird things like this, where to our withdraw function, I provide my name, my account number, but Mia's account balance, right? There's nothing preventing me from doing that because there's nothing that actually fundamentally ties the account information corresponding to one account together. All right, so this could possibly result in undefined behavior, and it's a relatively simple mistake to make. Okay. One way that we could improve this is to just bundle everything together into a dictionary. I think you covered dictionaries in Python either in November or possibly this past Sunday. But in case you haven't already, this is what a dictionary looks like in Python. We denote a dictionary using these curly braces here. So a dictionary is sort of like a list, except instead of using numbers as indices, as we do in a list, we use these user-specified keys. So here the keys are owner, number, and balance. All right, and we can access the values that we store in a dictionary using these keys along with this square bracket notation. So we would access the owner of my account using this my account and then square brackets and then owner. Okay. All right, so that's just a little bit of review again, and now let's switch over to the Google Colab notebook and do our first warm-up exercise. So we're going to write a function that allows us to transfer money between accounts. Okay, so transfer ABX should first check whether the balance of the account A, which again is a dictionary, it should check whether the balance of account A is at least X, and if it is, then it should transfer X dollars from A to the account B. And otherwise, it should print an error message to the screen. All right, so I'm going to give you, let's say, 3 minutes to sort of do that as a warm-up. Again, if you want to actually edit the code in the Colab notebook, you'll have to make a copy of it. So yeah, just make a copy of the notebook and then you can edit everything that's in it as you please. And you can also run snippets of code just like you did this past Sunday and last November as well. Okay. So does anybody have any questions before I let you do the exercise? Any logistics questions or content questions? Um, oh, can I have a link? Andrew, could you post the link again if that's okay? Yes, there it is. Perfect. Thank you very much. Okay. So I'm not seeing or hearing any other questions. Um, Again, I guess if you have any questions at any point, you can either unmute your microphone and just ask me verbally, or you can just post anything to the chat. I'll do my best to keep an eye on that as well. All right, so again, I'll give you, let's say 3 minutes just to do this little warm-up exercise here, just so we can get accustomed to programming in Python again. All right, good luck. Okay, so that was approximately 3 minutes. So hopefully this exercise wasn't too hard. I guess This is one example of what the transfer function might look like. Again, A and B are dictionaries that represent bank accounts, so they have balance, owner, and number as keys. So all the transfer function has to really do is, first of all, you have to check whether the balance of account A is at least X. And if it is, you subtract X from the balance of A and add X to the balance of B. And that would be equivalent to transferring X dollars, I guess, from account A to account B. And otherwise, we are just going to print an error message to the screen and do nothing. Okay, are there any questions about that exercise? Okay, perfect. Yeah, I'm not seeing anything in the chat, so I'm going to switch my screen back over to my slides. Perfect. Okay. So there are still a few problems with this approach, this approach of using dictionaries to represent bank accounts. So the first problem is that it's usually bad practice. It's usually a bad idea to duplicate large blocks of code like we do here. So first of all, it unnecessarily increases the size of your program. You're just adding a bunch of lines. It also makes your code a lot more difficult to maintain. So what do I mean by that? For example, let's suppose we wanted to add another piece of information to our bank accounts. For example, an interest rate, if we're trying to represent savings accounts. If we needed to do that, what we would need to do with this dictionary-based approach is we would have to go through our entire program, find every single dictionary that represents a bank account, and add the interest rate as a key to those dictionaries. And that's what I mean by making your code harder to maintain. And finally, it just makes your program harder to read because you're just adding this unnecessary clutter with these redundant lines. And there's a couple more problems with respect to readability. So first of all, it isn't immediately clear, looking at my account and Mia's account, that these variables represent bank accounts. You have to actually infer that yourself as the reader from the code. I mean, again, if we just look at my account and Mia's account on their own, maybe these represent credit cards. I mean, it's not immediately clear to me as a reader, unless I wrote this code, what these variables actually represent. Okay. Yeah. These variables are just dictionaries, so they could theoretically store any information. So you have to kind of infer from the code that these dictionaries are supposed to represent bank accounts. Also, again, if I'm reading this code and I look at the transfer function that we just wrote, it isn't immediately clear that transfer is supposed to work on bank accounts, right? Python doesn't actually enforce any type information, so I could hypothetically call transfer with any kind of arguments that I like. And again, it would take some effort for me as a reader to determine that the transfer function is actually supposed to work on bank accounts. So it would be ideal if we could somehow bundle all of the account information together with operations like transfer that work on bank accounts. If we could just bundle all of the stuff that has to do with bank accounts together into one block of code, that would be great. And that is some very obvious foreshadowing for this next section, which is about classes and objects and the concept of object-oriented programming in general. So a much better way to approach our bank account implementation task is to explicitly define a data type that represents a bank account. So to do this, we define a class right here. So a class again, is just a user-defined data type that groups a bunch of information, or attributes as they're called, and behaviors, or methods as they're called, together. All right, so this class bank account that I defined here is actually my own custom data type. So it will contain all of the account information, that is the owner name, the account number, and the balance, and it also contains this transfer function inside of it as well. So we've bundled everything together in this nice clean block. So as you already know, Python comes bundled with a bunch of different data types like integers, floats, lists, strings, and so on. And this bank account is just like any of those other data types, except that I get to specify exactly what data it stores and what functions it can perform. So don't worry too much about the details of this program just yet. There's probably a lot about this that doesn't quite make sense to you right now, but I'm going to go through everything that you see here in detail. So what I want you to focus on in this slide is, first of all, how you actually define your own data type using the class keyword. So we just say class and then some name for the class. Here I'm using bank account, but I could name a class anything that I want. And I want you to notice how you actually create a new variable of your custom type. That's near the bottom here. So all we have to do is use the class name, again, that's bank account, followed by some parentheses to create a new instance of our bank account class. So if you run this exact program in the Colab notebook, so this is present in the Colab notebook, if you run it, you'll notice that this last print statement here, it displays the type of my account, which is, again, it's just bank account. Again, this is just a custom data type that we've defined here as a class. Just a little bit more vocab here. Again, there's a more formal definition of class, and these variables, my account and Mia's account, are called objects of class bank account. Okay, so a class, again, is a type, and an object is just an instance of that type. Okay, so there's a bunch of different kinds of analogies that people use when they're trying to explain the concepts of classes versus objects. I think the one that I found most illuminating, for me at least, when I was first learning object-oriented programming was this. So a class is like a form with a bunch of blank fields on it. So imagine like a rental application form or maybe a registration form for a website. Whereas an object is like a copy of that form with all of the fields filled in. So there can be many different copies of a single form, and we can fill in the fields of the form however we like on each copy. Okay, another analogy that I've heard a lot is that classes are kind of like blueprints for building a house, for example, whereas objects are like the actual houses that are built using those blueprints. Okay. Are there any questions about the information so far?
About the recording, we'll be posting it on YouTube afterwards.
Perfect, thanks. Okay. Yeah, so if there's no other questions, we will move on. Okay, so as I mentioned earlier, using objects of our new class bank account, all of the account information and the supported operations are bundled together into a single reusable block of code. So this concept of bundling things together actually has a fancy name as well. It's called encapsulation. And it's one of the fundamental ideas that makes object-oriented programming so nice to use. Okay. So we saw earlier that you can create an object of a class using the class name followed by some parentheses, right? So creating an object also has a fancier name. It's called instantiation. So instantiating an object means the same thing as just creating an object, okay? So when I say instantiate an object, that just means I'm creating a new instance of an object. So when we instantiate a new object, we also probably need to pass in some information that actually describes the object. Right? So in particular, for a bank account, we need to pass in the name of the account owner, the account number, and the initial balance of the account. If we don't save that information, what good is our bank account, right? We're not actually saving the information that we require. So to save this information, we use what's called an initializer method. In Python, this is denoted by init. Okay, that's right here. So this is two underscores. It might be a little bit hard to read here. It's 2 underscores followed by the word init, followed by another 2 underscores. Okay, so the init method takes as arguments all of the information that you need to initialize or instantiate a new object of the class. Okay, so we can see here that the init method takes 3 arguments representing the account owner's name, that's name here, the account number, that's num, and the initial balance of the account, that's this init balance here. Okay, now to pass in values for these arguments, you use the same sort of syntax as you would use for calling a function. So when you instantiate the object, you pass in these initial values in between the parentheses following the class names, or the class name. And these values are passed in order to the init method. So when I initialize bank account using Sean, followed by this account number, followed by 250, then Sean is passed in as the argument name. This number is passed in as the argument num, and this initial balance 250 is passed in as this init balance argument. So again, just like a function call. Notice that I've ignored this first argument self so far. This is intentional, but I will be getting back to self in a few minutes. For now, just ignore it. Now, in the init method, we need to save all of the given information to our bank account object. So to do this, we initialize what are called instance attributes. Here, these are called self.owner, self.number, and self.balance. So instance attributes are just the pieces of information that describe a specific object of our data type. And to assign values to an instance attribute called x, for example, we would use self.x. Okay, so these attributes that begin with self dot, these are all called instance attributes. Now, after we instantiate an object, we can access its instance attributes using dot notation, as you can see at the bottom of this slide here. So the first line here, we're using myaccount.owner to access the instance attribute owner of the myaccount object, right? So in this case, because we initialized myaccount with the owner name Sean, this myaccount.owner is going to give us the string Sean. All right, similarly on the next line, we're doing Mia's account.number, and that is going to give us Mia's account number that we passed in to the initializer method here. Okay. Perfect. So I've avoided it for long enough. What does this self mean, actually? So we've already seen it in a few different places of our code. What self means is this particular object. Okay? The self variable is automatically passed as the first argument of the init method, and it is automatically passed as the first argument when we use dot notation to call a method on an object. So when we initialize my account using this statement here, we enter this init method, and as I mentioned previously, self is automatically passed as the first argument to init. So when I'm in the init method while initializing this variable my account, self, this argument self actually refers to the object my account, right? So when I assign self.owner equals name on this line here, what I'm actually doing is I'm assigning my account dot owner equals name, because again, self is just sort of an alias for whatever object we're performing the operation on. In this case, we're initializing the object my account, and so self refers to my account. Does this make sense? This can be confusing when you first see it, but we'll practice this in the exercises as well, and hopefully it'll start to make a little bit more sense. Okay, perfect. So barring any questions, I will just move on. Okay, so I guess just another similar example. Again, looking at when we're initializing Mia's account now, when I'm in the init method while instantiating Mia's account, self is going to refer to the object Mia's account, right? Again, self just refers to this particular object. And as I mentioned earlier, self is also, it's not only automatically passed to the init method when we're initializing an object, it's also automatically passed as the first argument when we use dot notation to call a method on an object. So when we call myAccount.transfer here, we're calling the transfer method with the arguments Mia's account and 50. But as we can see, transfer actually takes 3 arguments. It takes self, other, and x. And again, self is something that's automatically passed by Python when we call a method on an object using this dot notation. Okay? So self in this particular call of the transfer method is going to refer to my account, because again, I'm calling transfer on my account. So when we're executing transfer here, self.balance on this line here is actually accessing my account.balance. All right. Now, when you are first learning object-oriented programming in Python, you will inevitably forget to write self as the first argument for some of your methods, which will result in errors. So for example, let's look at this small test program here. So here I'm defining my own class myInteger, and we can see we have an init method, nothing too surprising going on here. We're saving an instance attribute val, and we also support an add method here. And then we have this getRandom method at the bottom. Notice that getRandom doesn't actually take any arguments. There's no arguments between the parentheses here. And now at the bottom of this program, first what I do is I initialize, or I instantiate an object of myInteger, and I assign it to the variable x. And then what I try to do is I try to call x.getRandom. But remember that getRandom doesn't actually accept any arguments. And so, but we know that when we call x.getRandom, Python is going to automatically pass in x as the first argument of getRandom. It's going to expect to assign something to this self variable that we've become accustomed to. And so this is actually going to result in a runtime error. And you can try this yourself. This snippet of code is in the Colab notebook. And it's going to result in a type error because the number of arguments in the call, which is 1, because again, we're automatically passing in this self variable, the number of arguments in the call does not match the number of arguments in the method signature, which is 0. Okay, so hopefully the meaning of self makes a little bit more sense now. Okay, just one more piece of vocabulary before we go to another exercise where you can practice these concepts yourself. So a method whose first argument is self is called an instance method. Okay, so recall that instance attributes are pieces of information that are stored on an object by object basis. Instance methods are methods whose behaviors can differ depending on which specific object they're called, right? So instance attributes and instance methods are both inherently bound to this notion of self. All right, after this exercise that we'll be doing next, we'll see that it's also possible to store information and support methods that don't actually rely on self. Okay, but we'll get to that after this first, or I guess this first non-warm-up example. Okay, so let's go back to the Colab notebook now and do exercise number 1. So in this example, you're going to be implementing your own class representing a university student. Oh, yes, I see a question in the chat. There's a question about, is this similar to the keyword this in Java? So if we have any Java programmers that are attending today's lecture, yes, self is essentially the same thing as this in Java. Or in C++ or whatever. A lot of other object-oriented languages have a this keyword that, again, refers to this particular object. Python's equivalent of that is this self, which is passed in as an argument to instance methods and initializer methods. So that's a good question, hopefully helpful if you've used any other object-oriented programming languages before. Okay. So with that being said, let's get to the Colab notebook. I think I'll give you 6-7 minutes, let's say 7 minutes, to implement this university student class that's present in the Colab notebook, and then I'll meet you back here. Okay, good luck. Pressure to the people. Oh, thank you. I'll just mention again, just as a refresher to people who are just opening the link now, in order to actually edit the code in the Colab notebook, you'll have to make your own copy of the notebook first, and then you should be able to edit and run anything that's in the notebook. Okay, welcome back, everybody. So I believe that was about 7 minutes. Hopefully you all have at least an idea for a solution to this exercise. I guess one thing I forgot to explain, my apologies, before diving into this exercise was all this sort of garbage at the bottom of these code blocks. These are just tests to make sure that the class that you wrote actually satisfies the specifications that were given in the exercise. So you didn't have to actually modify any of this. This was just for your benefit, I guess, to check whether or not your student class that you wrote actually satisfies the specifications of the task, specification of the object that was given in the exercise description. Okay. So with that being said, I'll go through one possible solution to this. So the student class here is fairly brief. This is all that you really need. So again, a student has 3 instance attributes, right? A student has a name, a student has an age, and they have a GPA. Okay. However, to our initializer method, notice that I'm only passing a name and an age, right? So this was specified in the exercise description. Yeah, right here, we should only be able to provide their name and their age, and their GPA is just automatically initialized to 4.0. And so that's what I'm doing here, right? So we don't necessarily have to assign an instance attribute to an argument. We can assign it to a constant as well if we want. So that's what I'm doing here. I'm setting up my instance attributes. The set GPA function, again, takes a single argument x along with implicitly self as an argument. This might seem a little bit deceptive because in the exercise description I said set GPA takes a single float argument x. This is just sort of convention. Often in Python we don't really treat self as like a real argument of an instance method. That's just sort of implied. It's implied that set GPA is an instance method because it has to access the instance attributes of the student, right? It has to access self.gpa. So of course I have to pass in self as an argument. I have no choice. Okay. So you'll see that a lot in these exercises here. All right, so all this set GPA function is doing is again, first it's just checking whether the given GPA x is in the allowable range between 0.0 and 4.0. If it is, then it's going to change self.gpa to x, and otherwise it'll print an error. Okay, and then finally the last thing we had to implement was this is older than method. Again, this has to be an instance method because it has to access the instance attributes of the student upon which it's applied. Okay, so this is just returning a Boolean. It returns whatever self.age greater than s.age is equal to. Okay, and then again, everything past this is just testing. So all we're doing here is we're instantiating, I should say, 3 objects of class student named A, B, and C. The A is 20 years old, B is 22 years old, C is 20 years old. And then again, these assert statements are just checking whether things are satisfied by your program. And then we're calling the set GPA function a few times and then checking that the behavior of those is correct as well. Okay, and if all is good, when you run this using just the play button in the top left, as you've done before, it'll print all tests passed in the bottom here. Okay. So a lot of the exercises are going to look something like this. Try not to touch the assertion statements because those are just again meant to test whether your program actually satisfies the specifications of the exercise. Okay, are there any questions about this particular exercise? Okay, perfect. And we can continue. All right, so as I mentioned before we did that exercise, sometimes it can be nice to store some information that is related to a class, but it isn't specific to any particular object of that class. Okay? For example, let's suppose that we wanted to store a set that contains the account numbers of all existing bank accounts. If we used an instance attribute, then we would need to store a separate set for each object of class bank account that existed in our program. So here, my account, which is this object on the left, would have its own copy of this set here. Okay, and Mia's account, which is over on the right, it would also have its own copy of all the accounts that exist in the program. So this is clearly a waste of space. I don't need to store 2 copies of this set, but there is an even bigger problem here. If we wanted to add another account number to this set, then we would need to add the account number to the corresponding instance attribute of every single bank account object that exists. I would have to find every single bank account and add the new account number to the existing accounts set. And obviously that doesn't make any sense, right? So it would be much simpler to just use, for example, a global variable to store this set. But we want to avoid using global variables in object-oriented design. and we still want the set of existing accounts to be bundled up inside of our bank account class, right? Just for the sake of code organization. To do this, we can use what's called a class attribute as opposed to an instance attribute, right? So a class attribute stores information for the entire class rather than for a specific object of the class. We can declare class attributes outside of all the class methods. You can see in this class bank account, I'm declaring existing accounts, which is a class attribute, and it's not, this declaration isn't inside of any method. Okay, so I can just declare it outside everything. And so we don't actually need to initialize class attributes inside of the init method, right? We can initialize it. Here we're just initializing existing accounts to an empty set, and that initialization is run when Python, I guess, sees your class definition. So as soon as the class is defined, all of the class attributes are initialized. Now we access class attributes using the class name dot attribute syntax, right? So as you can see, we can access the set of existing accounts using bank account dot existing accounts. All right, and this dot add method is something that's supported by sets in Python. It just adds the given item to the set. All right, so this is just adding my account dot number to the set bank account dot existing accounts. Perfect. So as you can see by this program here, we can also access class attributes inside the methods that are defined in the class, right? So like we're doing right here. So we could add accounts to the existing accounts attribute in our init function. You can see that what I'm doing here is I'm taking the account number of the newly instantiated bank account, which is num, and I'm adding it to the bank account dot existing accounts set on this line here. Notice a key thing here is that even in the methods that are actually defined in bank account, we need to say explicitly bank account dot existing accounts. We can't just write existing accounts. We can't leave out this bank account dot. Python's going to complain about that. So always make sure whenever you're accessing class attributes, you're using this you're using this class name dot syntax. Okay. Do class attributes make sense to everybody? Okay, again, just feel free to type in the chat anytime. I will try to keep an eye on the chat and answer any questions as they come in. All right. So I've explained what class attributes are. Now I'm going to go into an example that can illustrate sort of the wrong way to use class attributes. This is a hiccup that can happen when you're learning Python quite easily. Okay? And this also sort of illustrates the difference between class attributes and instance attributes in Python. So let's go through this scenario that's illustrated in this program here. And again, this program is present in the Colab notebook. So the purpose of this example is to show you what can happen when you use dot notation on an object to attempt to access a class attribute. All right. So if you use self dot or x dot, where x is an object, to try to access a class attribute. Okay. So as you can see, in this example program, we have a custom class here called myClass, and it has a single class attribute called class adder here. And its initial value is shared. Okay. So first, what I do in this program is I instantiate an object of type myClass. Okay, so x is an object of myClass. The first print statement accesses the class attribute, class adder, in what I would call the wrong way. Okay, so we're using x.classAdder. We're using this dot notation on x to access the class attribute class adder. Python lets you do this. It lets you use the dot notation on a specific object to actually access the value of class attributes. And so we can see that the first print statement here actually correctly obtains the value of class adder. It prints out the value shared here. Okay. The second print statement here is just the proper way to access a class attribute using myClass.classAdder. Okay, this is always how you should access class attributes. Afterwards, we call this x.change method. Okay, and what x.change does is it assigns a value to self.classAdder. At first glance, you might be thinking that self.classAdder is referring to the class attribute, right? It's referring to this here. But in fact, it's not. When we use self, we're accessing an instance attribute of the current object, right? So what we're actually doing here is we're creating a new instance attribute for x called class adder. Okay, so now x.classAdder and myClass.classAdder actually refer to different things. So the third print statement here is going to print out instance. All right, because we have assigned the value instance to the instance attribute self.classAdder, or I should say x.classAdder. And then finally, the fourth print statement, where again, we're accessing the class attribute in the correct way, it's going to print out shared because, again, we have not changed the value of the class attribute here. We have actually created a new instance attribute. So this is a common pitfall when you're first learning about class attributes in Python. You have to be careful. I would advise never use self.blah to access a class attribute, and never use x.blah to access a class attribute. The same thing, the same weird situation would happen if we replaced x.change here. If we replace this with x.classAdder equals instance, that would also create a new instance variable for the object x. So the same thing would happen. And you can try that out in the Colab notebook if you want. Okay, moral of the story is just use class name dot class attribute to access class attributes in Python. Okay. With that example done, let's go to static methods. So similar to class attributes, we can also define methods in our class that aren't associated with any particular instance of the class. So in Python, this means writing a method whose first argument is not self, right? Such a method is called a static method. So again, for example, let's suppose we want our bank account class to be able to generate new account numbers that differ from all of the existing account numbers. If we used an instance method for this, this is what that would look like. We would need to accept self right here as an argument to our method. However, as you can see at the bottom of our program here, before we can actually call generate account number, we need to have access to a bank account object. And if we don't have any bank account objects to work with, we need to do this weird instantiation of a dummy account in order to call this generate account number function. Right? Because before we have any bank accounts, we can't actually pass anything in as this self here. All right, so only after I have this object here can I use dot notation to actually call generate account number. But again, this doesn't really make much sense. generate account number doesn't actually depend on any instance of class bank account. I should be able to call this method regardless of whether I have any bank accounts in scope or not. Okay, so to get around this, we can use a static method. So yeah, again, I guess another problem, an obvious way to see the problem here is just notice we're taking an argument self here, but we're not using self anywhere in our code of generate account number. Okay. So that's an easy way to identify which methods you can actually make static. If you're not using self, there's no reason to pass self in as a parameter, as an argument, I should say. So when we remove self from the list of arguments to our function or to our method, what we end up with is a static method. So similar to class attributes, you can access a static method using the class name dot method syntax. Okay. And again, so sorry, this is illustrated here, right? So we're using bank account dot generate account number followed by parentheses to call our static method that's defined in class bank account. And again, self is not automatically passed as the first argument when you call a static method in this way. So I'm allowed to use static methods that have no arguments at all, like this. Okay. Yeah, sorry, this is all stuff that I just said verbally. All right. Does anybody have any questions about static methods or class attributes before we move on to the next exercise? Okay, perfect. So yeah, we're going to move on to, oh, there's a couple questions. So generate account number is a static method. Yes, in this example, generate account number here is a static method. Notice that it doesn't have self as an argument here. All right. Not a problem. Okay. Yeah, so we're going to move on to the second exercise set in the Colab notebook. Again, if you came in late, remember to duplicate the notebook so that you can actually edit the code and run it on your own machine. Oh, and there were a couple of, this set of exercises is a little bit longer. I'm just going to explain a few things before we get started. So let me just share the screen. Okay, so this is the second exercise set here. So there's 3 questions. First one, fairly self-explanatory, I think. The second one is a little bit different. So here I'm just asking you to identify whether certain calls in a Python script are to static methods or to instance methods. Okay, so every line that has a comment next to it that says what kind of call is this, those are the types that you're trying to identify. So here we're calling bank account dot generate account number. And so in call type 1, which is the next variable here, we are going to fill in whether or not I think this is a static method or an instance method call. That is bank account dot generate account number, whether that's static or instance. Okay, and you'll do that for all 5 of these call type variables here, and then you should be able to just run the notebook in the end, or run this code snippet in the end. And if you got all of the answers right, it should print out all answers are correct. Okay. Another thing is before you actually run this snippet of code, you're going to have to run the code that contains the bank account class and the code that contains the myInteger class. Okay. So if you haven't already done so, scroll up in this notebook, We have the bank account class right here under class attributes and static methods. Just run that. And then scroll up. And we have the myInteger class here. This is in the what is self section. So we run that, and then the notebook will remember the class definitions of myInteger and bank account after you've done that. And then you should be able to do the exercises. And then finally, the third exercise is again asking you to implement another class. Okay, so it's a bit of a longer exercise set, so I will give you a little bit longer to get through it as well. Let's say 10 minutes to get through these exercises, starting the clock now. And again, if you have any questions, feel free to just drop them in the chat. I'll try to keep an eye on the chat during the break as well. All right, good luck. Too bad. So I guess, does anybody have any ideas about question 1 here? Feel free to say whatever you think is wrong with this class definition in the Zoom chat, and I can sort of keep an eye on it. Get breed, this method here, there might be an issue there. Anything perhaps a little bit more specific about it? What exactly is wrong with get breed? Breed parameter is not needed. Yeah, that's a good catch there. So yeah, we're not actually using this breed parameter anywhere. We're accessing self.breed here. Does anybody have any other ideas? There's actually a couple other, maybe not mistakes, but sort of idiosyncrasies with this class definition. But yes, that's a good catch. Breed parameter is not needed. Excellent. Okay. Yes. So somebody's saying breed isn't being set in self. So breed isn't being set as an instance attribute. That's correct. You can see that we're not actually setting breed in our initializer method here. And this is actually sort of two mistakes. First of all, in get breed here, we are accessing a class attribute using self.breed. Again, this breed here is a class attribute because it's declared outside any of the class methods, right? So first of all, I'm using self.breed to access the class attribute breed. That's not going to result in an error here. You won't actually get any like weird behavior unless you actually assign a value to a class attribute in this way. So this is technically correct, but a little bit weird. More importantly, though, is there's sort of a semantic issue rather than a syntactic one here. Breed probably shouldn't be a class attribute, right? Because breed is something that describes a specific dog. I should probably be able to actually take breed as an argument to my initializer method. And as was mentioned, I should be setting an instance attribute for self.breed here and setting that to be the passed in argument. Okay, so this would make more sense, and I would have to delete this class attribute declaration as well. And this probably makes more sense. And again, I delete that argument as well. So excellent. Yes, those are I think it's reasonable to identify those as errors in the class definition, in the original definition. Okay, excellent. Now, next, we're identifying the types of method calls, whether they're static or instance method calls. You should have static, then instance, 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 and then static. So why is the first one static? Well, we're doing bank account dot generate account number. That I already said that was a static method call in the slides, but more importantly, we're using class name dot method. So that automatically identifies this as a static method call. Next, we're calling the transfer method on account to. We're using this dot notation on account to, which is an object of bank account. And so we know that we're calling this method on an object of bank account, and so this is an instance method call. So ACC2 is going to be passed in as the self parameter, as the self argument for transfer. Get an error for the first one. Let's see. Okay. I mean, it seems to be working okay here. There might be an issue with the way I set this up was using these secrets in the Colab notebook. If you're getting errors when you have the correct answers here, don't worry about it too much. It's probably some issue with the notebook itself. But yeah, the correct answer for the first one is static. So if it's giving you an error there, don't worry about it. Okay, sorry about that. All right. Yeah, second one is instance. Third one, again, we're calling an instance method here because we have an object, and then we're using dot notation to access a method. And then the third or the fourth one is again an instance method call because we have an object of type pd.dataframe. This is something that you'll probably recognize from the workshop that you attended on Sunday. So we're initializing two objects of type dataframe here, and then we're adding them together using this df1.add function or method. And because we're using dot notation on a particular instance of a class, this is an instance method call. Okay. And then finally, the last one, again, we're doing an add on two data frames, but this time we are calling add as a static method call, right? Because we have the class name, and then we're doing dot add, and then we're adding these two data frames together. So as you can see here, a class can actually support static and instance versions of the same method. This is often done just for flexibility. And this is all over the pandas library, which is something that you had a chance to experiment with on Sunday. So just keep an eye out for that. Again, neither of these is better than the other. It's just a matter of personal preference mostly. Okay, so hopefully those all make sense. And again, I think probably the quote unquote marking of this exercise doesn't work because the secrets aren't set up correctly. So my apologies for that. But yeah, the correct answers are static, instance, 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 then static. Okay, and then finally, we're implementing a class to represent a trivia question. And so this should be familiar. This is similar to the last exercise where you're implementing your own class for a university student. Setting up all of the instance attributes should be familiar by now. What we have to save is the question, all the answers, and which answer is correct. The first perhaps interesting thing about this solution is notice that I've decided to make welcome message a static method. It doesn't accept any parameters because there's no need for it to accept any parameters. All it has to do is return a string that has some sort of welcome message. So there's no reason for the welcome message to be an instance method. Answer, on the other hand, has to be an instance method because we need to access the correct answer. That is the self.correct instance attribute. Okay, and then the rest of this is just testing your code. All right, hopefully all of that made sense to to everybody. If there's anything that I can clarify, please feel free to post a question in the chat. Okay. So let's switch back over to the slides. And we'll do, could you explain when to use init? Okay, sorry. Let me go back to the notebook. Yeah, so, yeah, there we go. So init is something that's automatically called when you instantiate an object of a class, right? So when I instantiate a new trivia question, like I'm doing right here, init will automatically be called with the given parameters. You don't have to define init in your class definition if your class doesn't need to save any instance attributes, right? The purpose of init is to set this stuff up. So to save all of the instance attributes that you need in order to perform any of your instance methods, right? So if you didn't need to save any information, you don't actually have to have an init function. Python's default will do fine for you. Okay, perfect. Thank you for the question. And if there are no other questions, we can move along. Again, we're going to be doing the last section of the presentation now. Okay, yeah, there we go. All right, so occasionally we are going to encounter types that are specialized versions of other types. So, for example, in the real world, a poodle is a specialized version of a dog, an iPhone is a specialized version of a smartphone, and an integer is a specialized version of a real number, right? Notice that all of these are one-way relationships. So all poodles are dogs, but not all dogs are poodles. So this sort of relationship between two types can be represented in object-oriented programming using what's called inheritance. This is another fundamental concept that separates object-oriented programming from other coding styles. Okay, so for our first example of inheritance, let's consider three different classes: cat, dog, and animal. So clearly cat and dog are just more specialized versions of animal. A specialized subclass, like cat or dog, inherits all of the attributes and methods of its more generalized superclass, which in this case is animal. So in this example, objects of class animal have three instance attributes, which are specified here. They store the species, the age, and the height of the animal. Okay, and they also support one instance method called introduce. And this just prints an introduction string for the animal. Okay, objects of type cat support the meow method, and objects of type dog support the bark method. Since cat and dog also inherit everything from the class animal, cat and dog objects also have species, age, and height as instance attributes, and they support introduce as an instance method. Again, they inherit everything that is defined in the class animal. Note that using inheritance in this example makes a lot of sense because cat and dog need to support their own unique methods, right? We don't want dog objects to be able to meow, and we don't want cat objects to be able to bark. So that's why we need to separate them into two distinct classes here and use this inheritance design pattern. All right, so this is what inheritance looks like in Python. So to declare a class as a subclass, we again use the class keyword as normal, and then following the class name, which in this case is dog, we have these parentheses along with the name of the superclass, which in this case is animal. So this statement means that dog inherits from animal, and this statement here again means that cat inherits from animal. And notice that I don't actually need to change anything about animal in order to use it as a superclass. I just need to specify in the subclasses what is being inherited from. All right. Now, as you can see in this little example snippet here, I can call instance methods that are defined in the superclass of dog and cat. So here I've instantiated my dog as an object of dog, and my cat is an object of type cat. But you can see down here, I'm calling the introduce method on both of these objects. The introduce method is defined in animal. But since dog and cat both inherit from animal, they inherit the introduce instance method from animal as well. All right, and if I wanted to, I could also make an instance of the superclass. There's nothing preventing me from doing that. So if I had some more generic animal that I wanted to instantiate that wasn't either a dog or a cat, I could just instantiate animal as normal here. Okay, and of course, it would also support the introduce method because that's defined in animal. However, my monster here, which is an instance of animal, would not be able to either bark or meow. All right, hopefully that makes sense to everybody so far. Okay, so now we're going to learn about how to actually properly initialize subclasses. Okay, and to do this, we have to make use of something called the super method. Okay, so in the init methods of dog and cat, I was already actually using this super method. This is, again, crucial for programs that use inheritance. Okay, what super does is it returns an instance of the superclass, which in this case is animal. And so from the subclass, we can call any instance methods and access any instance attributes of the superclass using this super method, right? So what I'm doing here is calling super.init. And what that's going to do is it'll call init in the superclass of dog. Okay? So you can think of this super as it's kind of similar to self, right? So recall that when I instantiate an object of class dog, self refers to this particular dog that I'm initializing. Calling super also returns an object that refers to this particular dog, except that it accesses the instance attributes and methods that are in the super class rather than in the dog class. Okay? Now, super, what you generally use it for is to call an instance method of the superclass that has the same name as some method of the subclass. For example, init is always going to have the same name. So that's why we have to use super here. If I just tried to call init without using super, I would have an infinite sort of recursive loop in my program here, and it wouldn't work out nicely. Okay? But I can use, again, the super method to get around this. And this can actually be used for any method. This is not just for init, as we're going to see on the next slide. So let's suppose that I want to write a special version of the introduce method for my dog class. Okay, so the introduce method of the dog should first call the introduce method of animal, and then it should call bark. Okay, and to do this, again, I use the super method. The super method allows me to access the class animal. So if I call super.introduce, this will call introduce for that's defined in the class animal. Okay. And then to call the introduce method on an object of class dog, I can just use the mydog.introduce method. And because mydog is an instance of dog, Python is first going to look for definitions of introduce in the dog class. And only if there is no definition of introduce will it look at the parent class. All right. But because we have a definition of introduce here, it's going to automatically call the introduce method of dog. Okay. So hopefully that makes sense to everybody. I'm running a little bit short on time, so we have one final exercise that's sort of meant to illustrate the concept of inheritance. But I think what I will ask you to do is to just do the first question of that exercise. All right, just so we can get through it a little bit quicker. So I'll give you, let's say 5 minutes just to do, let's say 4 minutes, just to do the first question in exercise number 3 in the Colab notebook. All right, so I'll be back in 4 minutes. And again, if you have any questions during the break, feel free to post them to the chat, and I'll do my best to answer them. All right, good luck. Okay, so let's quickly discuss one possible solution to the first question of exercise number 3. Actually, give me just one moment here.